Students, in this video we'll see some of the left out concepts of the logarithmic function and exponential function, and we'll see exercise 5.5 second sum. Now we'll get into the topic, right? If you want to see our other videos, please click the right button at the top. Now log of x into y, I can write it as log x plus log y. Log x plus whatever may be the base. The base may be 1 or 2 or 3, any number. I can write it as log xy as log x plus log y. This is the first property of logarithmic function. Then the second property is log of x by y. I can write it as log x minus log y. Log x minus log y. Third property is log of x power n. I can write it as, I can take this power to the front, I can write it as n log x. N log x, whatever the base, you can use this with these three properties. And the fourth property is log of y base x. I can write it as log of y base b by log of x base b. Right? Now these three properties are simple to understand, but this property, suddenly why I am bringing this b inside here? I have log y base x. Why I am bringing this b inside it? Let me explain you with the help of an example. Now we all know that log is nothing but, when I write log of 27 base or 81 base 3, what is the meaning for it? 3 power what, I'll get 81, yes or no? So we know that 3 power 4 is 81, so the answer will be 4. Now if I give like this, log of 81 base 27, yes, in 27 powers, when I'll get 81, I don't know, it is a complicated answer, right? So in order to find this value, I'll use this property, right, which is a common number that is that can be used as a power for both. 3 power 4, we know it is 81, 3 power 3 is 27, so the common number is 3. So I can write it as log of 81 base 3 by log of 27 base 3. Can I write like this? Yes, that is what your property 4. Log y base x. Y base x can be written as log y base b by log x base b, right? Yx, y base b, x base b, right? Here it is 3. For some other question, the value of b may change. Here it is, the common number is 3. If the common number is 2, we'll put 2 here. If the common number is 4, we'll put 4 here, right? Now we know the answer for this is what? Log of 3 power what is 81? 3 power 4 is 81. 3 power what is 27? 3 power 3 is 27. So the answer for this is log of 81 base 27. The answer is what? 4 by 3, right? So these are some 4 properties for logarithmic function. Now we will get into the next concept. We have yesterday we saw what is an exponential function and what is a logarithmic function. We have done some 2 special exponential function and 2 special logarithmic function. 2 power x is also exponential function. 2 power x is also an exponential function. 3 power x is also an exponential function. 5.1 whole power x is also an exponential function. Right? There are many exponential functions. In that we have some 2 special exponential function. One is 10 power x. This we call it as common exponential function. Common exponential function. E power x is, we call it as natural exponential function. Natural exponential function. Okay, 10 we know that what is this e? This e is nothing but Euler number. Euler number, like that b must be greater than 1. This e is obviously greater than 1. So this e we call it as Euler number. So e power x we call it as natural exponential function. Same way we have log of x base 2, log of x base 3, log of x base any number. In that log of x base 10 we call it as log of x base 10 we call it as common logarithmic function. Common logarithmic function. And log of x base e we call it as log of x base e we call it as natural exponential function. Natural exponential function. Got it? So now we will get into the topic. These 2 things you have to remember it. Common exponential function, natural exponential function, common logarithmic function, and natural logarithmic function. Natural logarithmic function. Right? Now we will get into the sums of exercise 5.5. So if you take 5.5, we will use the concept of logarithmic differentiation. Okay. So first of all, we should know where we have to use that logarithmic differentiation. Right? Now in 2 cases we will use that logarithmic differentiation. The first case is when you have too many terms as a product. If you have only 2 terms as a product, we will use UV formula. If you have 3 terms, we cannot use UVW formula. But more than 3, we cannot extend the UVW formula further, so it will be complicated for us to proceed. So in those cases, right, if you have many terms as a product on the right hand side for us to differentiate, like for example y equal to, if I have a into b into c into d into e, for example, if there are 5 terms, right? Now it is difficult for me to use a UV formula continuously for this. So what I'll do, I'll take log y equal to all this a b c d. I'm just writing it as a b c d. Okay, this a is some function of x. Take a to be some x minus 1, x minus 2, x plus 5, x plus 9, like that. So it is difficult to differentiate like this. So if I take log on both sides, what will happen? Log y equal to log of a, B, C, D, E. Now if you use that property for first property, log A into B, I can write as log A plus log B, right? Yes, so I can write, we can extend that for 3 or 4 terms also. So log A, B, C, I can write as log A plus log B plus log C. So log of A into B into C into D into E, I can write it as log A plus log B plus log C plus log D plus log E. Now this is easy to differentiate. Log y is 1 by y into dy by dx. Log a derivative will be 1 by a. Yes, like that. Now this will be easy for us to differentiate. So for these type of sums, when the product on the right hand side is more terms, we have more terms on the right hand side as a product. What we will do? We will use the logarithmic differentiation. And the other cases, if y equal to x power 5 or x power 5 by 2, we can differentiate. If y equal to 3 power x, we have a formula. What is the formula to differentiate this? We have a formula for x power n into x power n minus 1. For here also we have a formula. Derivative of a power x is what? A power x into log a, right? So here base is variable, power is number, constant. Here base is number, constant, power is variable. What if it is both are variables like this? X power x or x power sin x. If both are variables, I cannot use this formula as well as this formula. So for these cases also, what we'll do? We'll use the concept of logarithmic differentiation. So this power is a problem. So if I take log on both sides, what will happen? I'll have log y equal to log of x power sin x. Now what I can do? I can bring this sin x to the front. I can write it as log y equal to sin x into log x. Now this is easy for us to differentiate. Sin x into log x, we can use the UV formula. So for these two types of cases, one is if I have some 3 or 4 products on the right hand side, product of 3 or 4 terms on the right hand side, we'll use this logarithmic differentiation. And when it is the right hand side, we have powers where both the base and power are variables like this. What we'll do, we'll use the concept of logarithmic differentiation, right? So this class also we cannot complete the introduction part. So that's it. We have completed the introduction part now. We'll get into the exercise 5.5 in the next video. Thank you. If you like the video, please click the like button, share with your friends, subscribe to our channel, and to get our regular notifications, don't forget to turn on the bell button. Thank you.